Hey guys, just to warn you, there's people working outside and my dog is going nuts. So welcome to my home. Sorry in advance if you hear him barking again. Okay, this is our third and final mini lecture of the week. We're talking about theory. I spent the last two talking about empirical theory and literature reviews. One thing that I'm a little worried about is that I might have conflated those two things more than I should have. So they are not the same thing. And I want to start today by being crystal clear on the difference between empirical theory and a literature review. A literature review is, as the name would suggest, a summary of the relevant literature. But differently, an empirical theory is the story that you as a researcher are telling about the phenomenon under investigation. And that theory, that story, is based off of three things. It's based off findings from the research literature. It's based off of your personal observations about the world and what you've seen in the world. And it's based on logic. The literature review comes from other people, and the theory comes from you. Okay, if that's not clear, you're still confused, let me know on Friday, shoot me an email, we'll figure it out. All right, not all theories are good theories, but all good theories have four things in common. And the first three good things, or things that all good theories have in common, are things that we've already talked about. They're testable, so we can observe real-world implications, we can gather data on key concepts, and we can actually test our hypotheses. They're generalizable, and so they apply beyond the data that we're using to test them. And they're parsimonious. They're simple. They don't have any unnecessary extraneous concepts or moving parts. Then the fourth quality of a good theory, and this is a necessary condition, is that a good theory will link together its key concepts in a way that creates a causal argument. Causality is really, really important here. Causality is worth taking a closer look at. When we're trying to understand causality, we're really trying to get at which factor or which factors, which independent variable or variables primarily explain movement or variance in the outcome of interest. So when we're trying to understand causality, we're really trying to say, this thing is changing, it's moving up and down. Sometimes it's high, sometimes it's low. What is causing that change? What is making that happen? Excuse me. In order to establish that causality, we have to meet four key conditions. In other words, in order for us to say, I think it's this independent variable or this set of independent variables causing this outcome of interest, we have to establish four things. One is correlation. So there needs to be a measurable relationship between the independent and the dependent variables. It actually has to be the case that they seem to respond or move together or be related in some statistical, meaningful way. The second thing is time order. The independent variable needs to come before the dependent variable. So to say that mixing baking soda and vinegar causes a science fair volcano explosion, you actually have to mix the stuff together before it explodes. If it exploded and then you poured in the baking soda or the vinegar, you couldn't say, hey, look, the vinegar caused the explosion, right? Because the explosion happened first. I'm clearly homeschooling my children. To say that, what's a better example? To say that that mosquito bite is making this itch, you need to have been bitten by the mosquito before the itch begins, right? Time matters. More than time, order matters. The independent variable has to come before the dependent variable. The thing you're using to explain something has to happen before the something happens. The third thing, or the third condition you need to have to establish causality is a logical causal mechanism. There needs to be a reasonable reason, you know what I mean, that variance in the dependent variable is caused by movement in the independent variable. It can't just be this happens and then that happens. It needs to be this happens and for these reasons, this thing happens next. There needs to be some story linking the two and explaining what you're trying to explain that makes actual sense. So with mosquitoes, it's that you get bitten by the mosquito, which produces a histamine response in your skin, which feels to our brains like an itch. I don't actually know what the chemical reaction in the volcano is, but there is one, so that when you mix the ingredients, that's what causes the explosion. So there needs to be a logical, reasonable causal mechanism. And then the fourth condition, or the fourth key condition to establish causality, is non-spuriousness. It cannot be the case that variance in both your dependent variable and your independent variable are caused by some third factor that we're not measuring or working into our story at all. So spuriousness is when it looks like X causes Y, but there's really some unobserved Z that we aren't talking about that changes both X and Y. There's really some unobserved factor out there that we're not focused on that is causing change in X and causing change in Y. So here's some real world examples. There is a link, it's on the slide, between the number of swimming pool drownings that happen and the number of movies that Nick Cage appears in. What this graph doesn't show is that correlation is actually monthly, not annually. So both of those things tend to happen more often in the summer. In this case, there's a spurious relationship between Nick Cage appearances and swimming pool drownings that makes it look like the more movies Nick Cage is in, the more people drown in swimming pools. But really, what's happening is that both Nick Cage movies and swimming pool drownings tend to happen in the summer. Right? So it's summer driving both responses. Less entertainingly, I could show you a graph that looks, and this is the usual teaching example, that as Americans eat more ice cream, more of us drown in swimming pools. But it turns out that, again, summer leads us to eat more ice cream than at other times, and summer causes us to be more likely to drown in a pool than at other times. And so even though it looks like it's the ice cream causing the drowning, it's really the summer causing both of those things. That's spuriousness. And if we don't think about the season, we could write a whole paper demonstrating that as Americans eat more ice cream, it causes them to fall in swimming pools. Right? It's important that we think about spuriousness and that we consider possible spuriousness and do our best to rule it out. That spuriousness, it's not causality. The idea that there's this other thing out there causing both of our factors means we can't say one of our factors causes the other, right? That's not causality, and a good empirical theory is causal. Okay. One last thing to cover this week. There's no smooth way to make this transition, so I'm just gonna, there you go. We need to look one more time at hypotheses, and it'll be quick. I think you really kind of understand hypotheses well right now. We know that hypotheses lay out the causal relationship between the dependent and independent variables. From there, we also need to differentiate between the null and alternative hypotheses for later hypothesis testing after we've collected data. The null hypothesis is denoted with a 0, so it's that H sub 0, and we read it as H null. The null hypothesis states that there is no relationship between your independent and dependent variable. Right? Null is another way to say none, or nil, or a 0. And so the null hypothesis says X is not related to Y. The alternative hypothesis is denoted with the letter A, and it's read as HA. The alternative hypothesis states that there is a relationship between your independent and dependent variables. It's the alternative to the null. The alternative to there being no relationship is that there is a relationship and it is positive or it is negative. So, for example, if we use the research question, what impact does education have on whether people vote? The null hypothesis, H null or H0, is education has no impact on voting. An alternative hypothesis, HA, is the more education a person has, the more likely they are to vote. So a null hypothesis says the relationships between X and Y don't exist. And an alternative hypothesis says the relationship between X and Y does exist and takes a particular form as positive, so as x increases, y increases, or it's negative, so as x increases, y decreases. Either way, the alternative hypothesis says there is a relationship. The null hypothesis says there is no relationship. And I think that's it. That is it for the week. I will see you on Friday.